Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about probability distributions. So this is actually an introductory video on probability distributions. There are going to be more videos discussing specific type of distributions. Now before we get started, this would be our website address, that is perfect-scores.com. Don't forget to explore that. And this would be our Facebook page, that is facebook.com/perfectscores. Don't forget to give us your valuable like here. Now let's go ahead and get started with probability distributions. Now what exactly is known by the probability distribution? Now probability distribution kinds of distributes what all different values a random variable can take associated with their probabilities. So let's suppose the random variable x is there, and let's suppose it can take value x1, it can take value x2, it can take value x3 all the way till xn. So these are the values that this random variable can take, and these are associated with their probabilities. That x can take a value of x1 with a p1 probability, x can take a value x2 with a p2 probability, p3 probability, and so on. So this is nothing but which is known as the probability distribution for this random variable x. Now another thing we have to understand here is that all these probabilities are definitely greater than 0. We will not be catering to some value of x whose the probability of happening is actually equal to 0, because then it doesn't make any sense. Then you'll have unlimited values there. So you'll only have those values whose probability is greater than 0. And another thing is that these some of these probabilities, that is p1, p2, p3 all the way till pn, is going to be equal to 1, which means the summation of pi with I equal to 1 and I equal to n is going to be equal to 1, because that means that we will not be leaving out any chance, or we will not be leaving out any probability or any value of the random variable x in this probability distribution. We'll be taking care of every possible value, right? So suppose you're understanding this point over here, guys, and the way we denote, let's suppose we want to individually denote this probability here, we would say the probability that the random variable x can take a value xi will actually be equal to pi, so which is this here, right? So the probability that the random variable x will take the value of x3 is equal to p of 3. So this is the general way we denote one of the individual probabilities for the probability distribution. So let's go ahead and use an example so that you can understand all this which I've explained here. Let's say we have this question. It says two cards are drawn successively with replacement from a deck of cards. Find the probability distribution of the number of kings. Now how many kings you can have? Now x is the number of kings. X is the random variable where you have the number of kings. And what are different values x can take? X can actually take 0 value where you have no king at all. X can take a value of equal to 1, and x can take a value of equal to 2. There can be 0 king, 1 king, or 2 kings. There cannot be more than 2 kings because you're only drawing 2 cards, right? So what is the probability of getting no king at all, right, when you draw 2 cards? Now you have a total of 52 cards. Out of 52 cards, how many cards are kings? 4 cards are kings, which means there are 48 cards which are not kings. So what is the probability of getting not king and not king? That will actually be equal to any of this card, that is 48, any out of 48 cards. Again, any out of 48 cards, because you're actually doing it with replacement. So suppose you're understanding this point over here. So if you kind of solve this, this is 12 times 4, 12 times 3, 4 times 12, 4 times 13, 4 times 12, 4 times 13, which is going to be equal to 144 by 169. And what about getting one king, right? So what about getting one king and one no king? That will actually be equal to the probability of getting a king, which is 4 by 52, into the probability of getting no king, that is actually equal to 48 by 52, into 2 factorial. Why this 2 factorial? If you don't know this 2 factorial, go ahead and watch the first few probability videos. It's actually the number of ways k and n can arrange itself. So if you kind of solve this up, this is going to be 1 by 13, this is going to be 12 by 13, so this over here will be 24 by 169. And what about the probability of getting 2 kings, which is going to be 4 by 52 into 4 by 52? That will actually be equal to 1 by 169. Now, if I want to have the probability distribution, now this is the random variable x, and these are the possible values that it can take. And what about their probabilities? So the probability that there's no king is going to be 144 by 169, which is there. The probability of getting 1 is 24 by 169, and probability of getting none is, 2 kings is 1 by 169, right? So that is there. I suppose you're understanding what I'm trying to say here, guys. And another important thing that you have to understand is that the sum of probabilities is equal to 1. This expression here. So you can clearly see if you add all the probabilities, you're going to get 144 plus 24, which is 168, plus 1, that is 169 by 169. The sum of probabilities is actually equal to 1. So that is something that we are sure about, right? So I suppose you're understanding this point over here, guys. Let's move forward now. Okay, so let's try to find what is going to be the mean of a random variable, or actually the mean of a probability distribution. Let's say, for example, I have the random variable x. It can take value 2, 3 or 4, and if the probabilities are exactly 1/3, let's suppose there is 1/3 probability, it will take value 2. There is 1/3, or let's say 2, 3, 4, 5, there is 1/4 probability, you'll take value 2, 1/4 probability, you'll take value 3, 1/4 probability here and 1/4 probability here. Then the mean of the random variable will actually be exactly this number, because there is an equal probability of x having any number. However, when these probabilities are different, then the mean will be changed, right? And mean will be more towards the number which has a higher probability of coming out as the value of x. Let's suppose if I say that the value of x can be 2, 3, 4 and 5, and the probability that it would be 2, it's 0.05, probability that it would be 3, that is 0.05, probability it would be 4, that is 0.1, and probability here, let's say, 0.8. Now you can clearly see that the chances of x coming out to be 5 are way higher. They are 80% as compared to these chances here, which are 20%, which means the mean will no longer be 3.5. The mean has to be more close to 5. And this is what do? We try to find the mean of a random variable using the properties here. Now what are these 2, 3, 4 and 5? These probabilities are nothing but the weights assigned to these random variables. These are the weights assigned. The more the probability, the more is the weight assigned to that number. So in that case, let's suppose if I say that, let me just clear this up. So if I say that there is a random variable x, and the random variable x can actually take any number, right? It can take number x1, it can take number x2, it can take number x3, and so on till xn. And these are their respective probabilities. That is this. Now what is this probability? This probability is the weight of this x1. That means we can actually say that the real terms, in real terms, the value of x1 would actually be in this probability. In over here it would be this probability, over here it would be this probability. So what I'm doing is I'm actually multiplying the respective weights into their numbers, so as for me to have a good idea about the importance of each number in the list. Now for me to find the mean of the random variable, I can say that the mean, which is denoted by mu, would be equal to the sum of all these numbers at the top. So the sum of all these numbers at the top divided by It has to be divided by the number of terms. Well, that is not required. Why? Because these weights, the probability is itself the chances of x1 happening divided by the total number of chances. So that means that n is invisible here, but it's actually there. So the mean over here is going to be equal to this expression, right? Because you don't need to divide by the number of terms, because that is already taken care of in the probabilities. That is, probability is actually, it already has the number of terms being divided by. So that means you're already dividing by the number of terms. That means this over here is the mean. And I can also say that that is actually equal to summation of xi into pi, where I is equal to 1 and I goes all the way till n. Now, mean is also known as the expectation. It's also known as the expectation of the random variable x. So it is also denoted as the expectation of the random variable x, which is actually equal to the mean, which is actually equal to summation of xi pi from 1 till n. So, this is also known as the expectation of the mean. So suppose you're understanding what I'm trying to do here, and let's use that in terms of an example here so that we understand it. So the question says that let a pair of dice be thrown and the random variable x be the sum of numbers that appears on the two dice. What is the mean? What is the mean and expectation, or say it has to be or, what is the mean or expectation of x? Now we have to find the sum of the numbers on the die, right? So the die can take 1, 2, 3, 4, 5, 6. These are the numbers that it can take. So what is the minimum possible sum there can be? Let's say, what is the minimum possible value that x can take, where x is the sum of two numbers. So the minimum possible value for x will actually be equal to 2. That is the minimum possible value of x. So let's try to find the probability of x being equal to 2. That will actually be, in how many ways can you get sum 2? There is only one case, 1 comma 1. That is the only way you can get sum 2. So the answer is going to be 1. That is one case divided by the total number of cases, which are 36, because we are throwing two dices. We're throwing a pair of die, which means they're going to be 36 cases. As you already know, this is 1 1 1 2 all the way till 1 6, 2 1 3 1 all the way till 6 1, and this is all the way till 6 6. So you know that there are 6 cases here, there are 6 cases here. That means they're going to be a total of 36 cases. Similarly, what is the probability that you're going to get the sum to be equal to 3 here? So the cases are nothing but 1 comma 2 and 2 comma 1. So you have only 2 cases, which means my probability is going to be 2 by 36. Similarly, what is going to be the sum to be equal to 4? You can clearly see that the sums are the combinations are 1 comma 3, 2 comma 2 and 3 comma 1. So the probability here is 3 by 36. You can clearly see a pattern is emerging: 1 by 36, 2 by 36, 3 by 36. For sum to be equal to 5, even if you calculate it, it's going to be 4 by 36. For sum to be equal to 6, it's going to be 5 by 36. And for sum to be equal to 7, it's going to be 6 by 36. And for sum to be equal to 8, it's 7 by 36. Okay, it's not 7 by 36. For sum to be equal to 8, if we try and calculate it, it's 2 comma 6, and it's 3 comma, 2 comma 6 and 3 comma 5, and then we have 4 comma 4, and then we have 5 comma 3, and then we have 6 comma 2. So there are a total of 1 2 3 4 5 cases. So that is again 5 by 36. So it's 1 2 3 4 5 and 6, and we're down to 5 again. And what about the sum till 9? What are the cases here? The cases are going to be the one case will go, the two case will go. It's going to be 3 6 and 4 5 and 5 4 and 6 3. So it's actually equal to 4 by 36. So if I try to find all the different possible probabilities, if I just erase the ink here, and if I try to find all the values of x, so what all different values x can take? X can actually be equal to 2 3 4 5 6 7 8 9 10, 11 and 12. These are the possible values of sum that can be there. The maximum sum is 12 and the minimum sum is 2. So the probability here is 1 by 36. The probability here is 2 by 36. It's 3 by 36, 4 by 36, 5 by 36 and 6 by 36. It's going to reduce again. 5 by 36, 4 by 36, 3 by 36, 2 by 36 and 1 by 36. So this is the probability of x or their respective probabilities. Now if I have to find the mean, that would be the expected value of x, which will actually be equal to the summation of xi into pi. So that is going to be equal to 2 into 1 by 36 plus 3 into 2 by 36, which is this, plus 4 into 3 by 36 and so on all the way till 12 into 1 by 36. That is this, right? So if you go ahead and calculate that, if you kind of take the 36 to be the LCM, you'll have a lot of patterns emerging here. You'll have 2 here, 3 into 2, 6 here, you'll have 4 into 3, 12 here, and then 20, and then 30, and then 42, then you have 40, 36, 30, 22 and 12, right? If you go ahead and calculate it, just all these small parts, and if you go ahead and calculate it, this is going to come out to be equal to 7, right? So I'm just going to spare the calculation away because don't want to waste your time on that. Now what is the meaning of this 7 here? The meaning of this 7 is that the expected value of this probability distribution is 7. That means on an average, if you throw a lot of times, if you throw the dice, let's suppose infinite number of times, your sum will actually be close to 7. Your sum will be equal to 7 because that is the expected value of the mean. Expected value of this probability distribution. That is, on an average, the sum is going to be close to 7 when the number of throws increase by, they keep on increasing. Your average value, your sum, your average value is going to be more towards 7. Right? So suppose you're understanding this point over here, guys. Let's move forward. Now we've already found the mean of mean of a probability distribution. Let's go ahead and try to see what will be the variance of a probability distribution. Now what do you mean by variance? Variance, it's something, if you've already watched the statistics video for class 11th, you would know that variance is something which tests how far are the numbers away from the mean. How far are the numbers away from the mean. I'm going to show you with two examples, right? With two random variables. Let's suppose we have two random variables. We have random variable x1 and we have random variable x2, right? Let's suppose the expected value of x1 is actually equal to 2, let's suppose 3, and the expected value of x2 is, let's suppose, is equal to 4. Now it's equal to 3 again. Now if the expected values are equal to 3, that does not mean that the probability distributions are identical. There is no way that we can say that the expected values will say that will say something about the probability distributions. Now why is that? Because there is a possibility that all the random value, the value of 3 can only be with the probability of 1, or it can be 4 with a probability of 0.5 and let's say 2 with a probability of 0.5. So there can be so many different probability distributions that actually can happen. An expected value by no way can actually tell you what that probability distribution is going to be like. And for us to identify that, what do we do is we try to find the value of variance to check how far the probability distribution or how diverse the probability distribution is. Because if the variance is equal to 0, that means there is no dispersion in our probability distribution. That means a random variable is going to take a value with probability equal to 1. However, as the dispersion increases in a set, as the dispersion increases in a set, the variance is going to increase, which means our set is going to be a little bit more diverse than the previous set. Now, how do we actually find the variance? Now, variance is something, what is variance? Variance is something that we denote as, this number here. Variance of a random variable x is denoted by this number here. That is actually equal to the expected value of that number from x, the expected value of x from its mean. That will actually tell us the deviations from the mean, and we square it up because the negative deviations and the positive deviations are supposed to be taken care of, right? So, for you to know more about variance, go ahead and watch the statistics video. There is a lot to be learned there, right? But right now, I suppose you're understanding what I'm trying to say, that the variance is equal to the expected value or the mean value of the deviations away from the mean, and we square the deviations because the summation of the deviation from the mean is always going to be equal to 0, and we square it up because we need to cater for the negative deviations as well and the positive deviations as well. I'm going to use a small little example to justify this expression here. Let's suppose I have a set, and set has these numbers. Let's say 0, 1, 2. These are the numbers, or let's say 1, 2 and 3. These are the numbers in that set. Now the mean of this set is going to be 2 definitely, and what about its variance? Well, the variance is definitely not 0 because the set is a little bit dispersed. But if I calculate the deviations from 2, this is -1 here, this is 0, and this is +1 here. This number is 1 away from the mean. This number is exactly at the mean. This number is 1 ahead of the mean. And if I add the deviations from the mean, it's always going to come down to 0 because the negative deviations will kind of cancel out the positive deviations. For me to remove that problem, what will I do is I will square the deviations up. I'll call it 0, 1 and 0, and I'll say yes, this set has certain variance, which is why I square this up, right? Just a little little explanation that I've provided. Why have I squared this up? And this x minus mu, what is the significance of x minus mu? That it tells us that how far are the numbers deviated away from the mean. Because if, let's suppose, I have these numbers x1, x2, x3 all the way till x of n, and mu is the mean, and x minus mu will actually give me the deviation from the mean. And if all the numbers are same in the set, let's suppose if all the numbers are equal to the mean, then the variance is going to be equal to 0, which will actually be justified by this expression right here, right? So suppose you're understanding this point. Now let's go ahead and try to explore the expected value of x minus mu whole square. Now this is what we have to do. Now that is actually going to be equal to the summation of I equal to 1 all the way till n of so that would be equal to the value of xi minus mu whole square multiplied by its probability distributions, right? Because we already know from the previous videos that the expected value is equal to the summation of pi into xi, where xi over here in our case is equal to xi minus mean whole square. Now if I kind of try to open this up, so I'm just going to talk about the right hand side now. So if I kind of open this up, this is going to be the summation of xi square plus the mean square minus 2 mean into xi, mean doesn't have an I at here, into the probability of xi. Now if I kind of again multiply this probability to these sides, I'm going to get the value of summation of xi square into the probabilities of xi plus summation of mu mean square into the probability of xi minus 2 times summation of mean into xi into the probability, right? Now you know that summation of constant is, whenever we do the summation of constant, that constant comes out. So in this case we're going to have the summation of xi square into the probability plus So this mean is a constant into mean square into summation of pxi. Minus 2 into mean is actually a constant. So mean is going to come out into summation of xi into pxi. Now one thing that we already know that the summation of p of xi is actually equal to 1. So if we try and use that, this over here, this is going to remain intact because this is multiplied by xi square. So this is there, plus mean square into summation of pxi, which is actually equal to 1, minus 2 mean minus 2 mean square. Why mean square? Because this expression is actually equal to mean. You can clearly see that summation of xi into pi is actually equal to mean. So it's 2 mean square. That means this comes down to be equal to summation of xi square into pxi minus mean square, which is actually equal to the expected value of x square. This is nothing but the expected value of x square. You can clearly see that is summation of xi square into pi minus the expected value of x whole square, which is actually equal to the variance of a random variable x. So the variance of a random variable x is equal to the summation of xi square, summation of xi square into pxi, which is actually equal to the expected value of x square minus mean is nothing but, you already know that summation of xi into pxi is actually equal to mean or the expected value of x. So that is expected value of x all the way till square. So that is there. Suppose you're understanding this point here, guys. Let's go ahead and solve a question on this. So the question is asking, find the variance of the number obtained on a throw of an unbiased die. So what are the different values that unbiased die can take? It can take the value 1, 2, 3, 4, 5 and 6. And what are the probabilities that it can take? Well, the probabilities are all equal, that is 1 by 6, 1 by 6, 1 by 6, 1 by 6 and 1 by 6. Now we are supposed to find the mean and the variance. Okay, so we're only supposed to find the variance of it. So the variance of this is going to be equal to the expected value of x square minus the expected value of x whole square. So what is going to be the expected value of x square? So the expected value of x square will actually be equal to the summation of xi square into their respective probabilities. So what is going to be the summation of xi square into their respective probabilities? So what is this? This is nothing but xi, this is nothing but xi, and this is nothing but pxi. So xi square into its probability, 1 square into 1 by 6, that is 1 by 6, plus 2 square into 1 by 6, which is 4 by 6, plus 3 square into 1 by 6, which is 9 by 6, 4 square into 1 by 6, which is 16 by 6, 5 square into 1 by 6, which is 25 by 6, and then we have 6 square into 1 by 6, which is 31 by 6, 36 by 6. So if you go ahead and calculate that, that if you kind of add this up, 36, 25, 16, 9 and 4, 36 plus 20, 25, 16 and 9 is also 25, that is 50, 50 and 6 is 86, 86, 90, this is going to be 91 by 6, sorry, 91 by, it's going to be, this is 6 here, so it's going to be 91 by 6. And what about the expected value of x? So the expected value of x is going to be simply the summation of xi into px. So that is going to be 1 by 6 plus 2 by 6 plus 3 by 6 plus 4 by 6 plus 5 by 6 plus 6 by 6. So which is going to be all the way till sum till 6, which is going to be 6 into 7 by 2, that's going to be 35, 35 by 6. And we are supposed to find the variance. So the variance is nothing but the expected value of x square, which is 91 by x, 91 by 6, minus the expected value of x whole square. So minus 35 by 6 whole square. So this over here is going to be 91 by 6 minus 35 square, which is 441 divided by 36. So into 6 and into 6, if I kind of subtract that, 91 times 6, it's 546. It's 546 minus 441 by 36, which is going to be equal to 35 by 12. So this is the variance of this this expression over here, of this probability distribution, that is on an average the difference between the terms is actually equal to this. Now one more thing that you have to take care is about the standard deviation, right? So the standard deviation, it's going to be equal to, we know that the variance of x is equal to expected value of x square minus the expected value of x whole square, and we know that the standard deviation is nothing but the under root of variance of x. So the standard deviation of this is going to be equal to under root of this whole expression here. Now let's go ahead and calculate that. This question says that two cards are drawn simultaneously from a deck of cards. Find the mean, variance and standard deviations of the number of kings. So two cards are drawn. So let's suppose x denotes the value of number of kings. Now the value x can actually take a value of 0. There can be no king at all. X can actually take the value of 1. There can be one king. X can actually take the value 2, where there can be two kings. And what about the probabilities? Now, what is the probability of getting no king? So, what is the probability of getting no king, right? That is going to be equal to no king and no king, which is going to be equal to 48 by 52 into, so since we're not doing it with the replacement, so the next card is going to have 47 cards out of 51, right? Because that's the way we'll do probability. So that's there. And what about the probability of getting x equal to 1? That is going to be equal to having a king and not having a king, which is equal to the probability of having a king, which is 4 by 52, into the probability of not having a king, which is 48 by 51, into 2 factorial, which is the number of ways k and n can arrange itself, right? So you can go ahead and watch the probability initial videos if you want to understand why this 2 factorial, or actually kn can arrange in kn or nk, which is why I have multiplied it by 2. That's another way of looking at it. The next thing is both coming out to be kings, which is going to be 4 by 52 into 3 by 51. So that is there. So what's the probability of their respected variables? So probability of x0 is this number. Now if I go ahead and calculate that, that's going to come down to 188 by 221. So if you just go ahead and calculate that, this one over here, if you calculate, it's going to be 32 by 221, and this one, if you calculate, it's going to be 1 by 221, right? Just I'm sparing you the calculation. Now we have to find the mean. What is mean? Which is the expected value of x. That is going to be 0 into 188 by 221, which is 0, plus this into this, which is 32 by 221, plus this into this, that is 2 by 221. So my answer is 34 by 221. So that is the expected value of x, which is the mean. And the question asked me the variance. So the variance is going to be, for variance, I have to first calculate the expected value of x square, which is going to be again 0 into 108 by 221, which is 0. 1, again this is 32 by 221, because 1 square is 1. 2 square is going to be 4, which is 4 by 221. So that is going to be equal to 36 by 221. So the variance is going to be equal to the expected value of x square, that is 36 by 221, minus the square of this expected value, which is going to be 34 by 221, all the way till square. So you can use a calculator to find this, and the standard deviation is nothing but, which is going to be equal to the under root of the expected of the variance, right? So that is going to be that. So I suppose you're understanding this point over here, guys, and thank you very much for watching this video. In this video we have completed, so that's all folks, right? So in this video we have completed the probability distributions. In the future videos we're going to be talking about some of the very important probability distributions, and like normal distributions and so on, and there we'll start again. So this would be our website address, that is perfect-scores.com. Don't forget to explore it. There's a lot of exciting stuff coming out here, and you can also ask me questions. You can practice exercises. Everything is there for you. So just don't forget to explore this. This would be our Facebook page to give us your valuable like, and if you have any feedback to give me, you can always contact me at perfectscores89@gmail.com. So this would be about this video, guys. Thank you very much for watching. I'll see you in the next one.